Ardennes Forest, 16th December, 1944. The German soldier emerges from the tree line at 20 meters, firing his Sturmgewehr as he charges. Private James McKinley empties his M1 Garand into the advancing figure. 8 rounds, center mass, all hits. The German stumbles but keeps coming. 15 meters now, training his weapon despite catastrophic wounds. McKinley's rifle is empty, the distinctive ping of the ejecting clip ringing in the frozen air. He reaches for his bayonet. Too slow. The German is 10 meters away. McKinley's hand closes around the entrenching tool strapped to his pack. One swing. The sharpened edge catches the soldier at the neck. The German drops instantly, dead, before hitting the snow. McKinley stands over the body, the small folding shovel still in his hand, blood steaming in the December cold. He counts 9 entry wounds in the dead man's torso, any one of which should have been fatal. The soldier had kept fighting anyway. The shovel had ended it in one blow. This scene repeats itself dozens of times across the winter battles of 1944 and 1945. American soldiers caught in close quarters combat after their rifles run dry, discovering that the humble entrenching tool on their belts kills more efficiently than the 18-inch bayonet they've been issued. After-action reports from the Ardennes, from Hurtgen Forest, from the Rhine crossings, all note the same phenomenon. When fighting moves to knife range, soldiers are abandoning their bayonets in favor of their shovels. The implements designed for digging foxholes are being sharpened to razor edges and wielded as weapons of last resort. Field commanders note the pattern with growing interest. The entrenching tool isn't merely adequate as an improvised weapon. In the brutal mathematics of close combat, it's proving superior to purpose-built alternatives. Longer reach than a trench knife, more impact than a bayonet thrust, faster to deploy than either. And unlike a bayonet, it doesn't require fixing to a rifle, leaving the soldier's primary weapon ready to fire. The reports pile up on desks in Washington. Someone reads them and realizes the implications. The United States military has accidentally created one of history's most effective melee weapons whilst trying to build a better shovel, and they've done it for less than $1 per unit. The story begins not with combat, but with dirt. By 1943, the American military has a problem that seems trivial compared to winning a world war. Their soldiers' shovels keep breaking. The standard issue tool, a heavy one-piece design weighing nearly 4 pounds, proves too cumbersome for rapid deployment. Paratroopers complain it's too bulky for their equipment loads. Infantry grumble that it's awkward to carry on long marches. Worse, the welded joints between blade and handle fail under hard use, leaving soldiers with useless implements when they need to dig defensive positions quickly. The Army's Quartermaster Corps reviews the complaints and issues a requirement for a new design. The specifications seem straightforward enough: lighter weight, collapsible for easy transport, robust construction, and cheap enough to manufacture in the millions. What they receive exceeds every expectation. The winning design comes from an unlikely source. John F. Barnes doesn't look like a revolutionary. Born in 1889 to a family of blacksmiths in Pennsylvania, Barnes grows up in workshops filled with the smell of coal smoke and hot metal. He learns metalworking the old way by watching his father shape iron on the anvil, by feeling how different steels respond to heat and hammer. At 17, he's producing his own tools. By his 30s, he's running a small manufacturing concern specializing in agricultural implements and hand tools. Nothing glamorous, nothing military, just well-made shovels and hoes for farmers. But Barnes understands something fundamental about tool design that many engineers miss. The best tools are the simplest ones. Complexity creates failure points. Simplicity creates reliability. When the military specifications cross his desk in 1943, Barnes sees immediately what's required. The Army wants a shovel that folds, which means introducing a hinge joint, which means creating a potential failure point. Most designers would reinforce the joint with complex mechanisms, adding weight and cost. Barnes goes the opposite direction. He designs a 3-piece tool with a radical simplicity: a T-shaped handle, a separate blade, and a single, robust hinge held together with just one pin. The blade can fold flat against the handle for transport, then lock open at 90 degrees for digging or extend straight for use as a cutting tool. The entire mechanism contains exactly 3 moving parts. There's nothing to break because there's almost nothing there. The genius lies in the materials and tolerances. Barnes specifies high-carbon steel for the blade, the same alloy used in quality knife making. He makes the blade slightly thicker than necessary for pure digging efficiency, adding mass that serves no agricultural purpose but proves critical for another use case he's already considering. The handle is forged steel, not wood, eliminating another failure point. The hinge pin is overbuilt, designed to handle lateral stresses far beyond what digging would ever require. On paper, it's simply a well-engineered entrenching tool. In practice, Barnes has created something else entirely, a weapon that happens to be useful for digging holes. The Army's adoption trials begin in early 1943 at Aberdeen Proving Ground. The testing regime is merciless. Engineers bury the prototypes in sand, mud, and gravel, then task soldiers with digging fighting positions as quickly as possible. They freeze the tools, heat them, submerge them in salt water, and drop them from aircraft to test paratrooper deployment scenarios. The Barnes design emerges from every test functionally intact. Competing designs suffer broken welds, bent handles, and seized hinges. The Barnes tool keeps working. Then someone discovers its other application, possibly by accident. A soldier tasked with clearing brush around a test trench uses the folded shovel to chop through a small tree. The sharpened edge cuts through 4 inches of hardwood in 3 strokes. An observer notes this in a report. Someone else reads it and thinks about close combat. Bayonet fighting has been part of infantry doctrine since the musket era, but actual battlefield effectiveness has always been questionable. Bayonets are long, which makes them effective for keeping an attacker at distance, but they're also slow to deploy and require substantial training to use effectively. Most soldiers in close combat end up clubbing each other with rifle butts rather than executing proper bayonet technique. Someone at the infantry board decides to test the entrenching tool against the standard M1905 bayonet in mock combat. The results are documented in a classified report that won't be declassified for decades. In simulated close-quarters combat, soldiers equipped with the Barnes entrenching tool achieve kills 30% faster than soldiers using bayonets. The tool's shorter length makes it faster to bring into play. The cutting edge, when sharpened, proves capable of catastrophic wounds with a single strike. The weight of the steel blade delivers more impact than a bayonet thrust. Most significantly, the tool can be drawn and used whilst the soldier's rifle remains ready to fire, eliminating the vulnerable moment required to fix a bayonet. The Army officially adopts the Barnes design as the M1943 entrenching tool on 15th March 1943. The contract specifies a unit cost of 98 cents. Production begins immediately at Barnes' factory and at dozens of other facilities converted to wartime manufacturing. By June 1944, as Allied forces prepare for the Normandy invasion, more than 2 million M1943 tools have been manufactured. Every American soldier landing in France carries one, strapped to their pack or hanging from their belt. The official designation describes it as an entrenching tool. The soldiers will give it other names. The first confirmed combat use comes on the 7th of June 1944, one day after the initial Normandy landings. Sergeant Michael Donovan's squad, clearing German positions near Sainte-Mère-Église, encounters resistance in a communications trench. The confined space makes rifles nearly useless. Donovan, leading the assault, empties his Thompson submachine gun into the first German position, then rounds a corner to find 3 more enemy soldiers at arm's length. His Thompson is dry. He draws the entrenching tool from his belt and strikes the nearest German across the face. The sharpened edge opens the man's skull. The second German lunges with a bayonet. Donovan parries with the shovel handle, then brings the blade down on the soldier's collarbone. The third German turns to flee. Donovan throws the tool like a hatchet. It strikes the soldier between the shoulder blades, the blade penetrating 4 inches. Donovan retrieves the tool, wipes it clean, and continues clearing the trench. He will receive the Silver Star for his actions that day. The after-action report notes his weapon of choice without comment, entrenching tool M1943. The stories spread through the invasion forces. Soldiers begin requesting sharpening stones from supply sergeants. Armorers find themselves honing shovel blades to knife edges instead of sharpening bayonets. By August 1944, a survey of frontline infantry companies reveals that 60% of soldiers have deliberately sharpened their entrenching tools for combat use. Officers stop discouraging the practice after observing its effectiveness. Some units begin conducting informal training in shovel combat, teaching techniques borrowed from axe fighting and medieval swordsmanship. The tool's versatility becomes legendary. Dig a foxhole in hard ground, chop firewood, open ration cans, and if the enemy appears at close range, end the fight with one swing. The winter battles of 1944 proved the tool's value beyond doubt. In the Hurtgen forest, where combat often occurs at distances measured in feet rather than yards, the entrenching tool becomes the weapon of choice for tunnel clearing and bunker assault. American soldiers, fighting through the frozen landscape, discover that their sharpened shovels cut through winter clothing and Wehrmacht greatcoats more effectively than bayonets. The added weight, which makes the tool slightly less efficient for digging, provides devastating impact when swung at a human target. Field surgeons treating wounded German prisoners note the characteristic wounds, deep lacerations from the sharpened edge, crushing trauma from the flat of the blade. The injuries are consistently catastrophic, far more so than typical bayonet wounds. A bayonet thrust might miss vital organs, might be turned by heavy clothing or equipment. The entrenching tool, swung with proper technique, delivers damage comparable to an axe blow. By war's end in May 1945, the M1943 has achieved a reputation entirely separate from its intended purpose. Official production figures show 4.2 million units manufactured between 1943 and 1945. Post-war analysis of combat reports reveals a startling statistic. In close-quarters engagements where melee weapons were employed, the entrenching tool accounts for more confirmed kills than the M1905 bayonet, the M3 trench knife, and all other edged weapons combined. The dollar shovel has become one of the war's most effective killing implements. The end of World War II should have marked the tool's obsolescence. Military doctrine in the 1950s emphasizes mechanization and firepower. Modern warfare, the theorists argue, won't require soldiers to dig foxholes by hand or fight with improvised melee weapons. The M1943 should logically be replaced by something lighter, more specialized, more modern. Instead, it goes to Korea. The Korean War, beginning in June 1950, proves the theorists wrong within weeks. American forces, pushed back to the Pusan perimeter, find themselves digging defensive positions in frozen ground. The M1943 performs flawlessly. When Chinese forces launched their massive winter offensive in November 1950, American soldiers again find themselves in close combat in confined spaces. The entrenching tool comes off belts once more. At the Chosin Reservoir, Marines use sharpened M1943 tools to defend their positions against human wave attacks. The frozen ground prevents rapid entrenchment, but the tool serves its other purpose. Reports from the withdrawal note Chinese casualties with characteristic shovel wounds. The tool that killed Germans now kills Chinese and North Korean soldiers with equal efficiency. Vietnam brings new challenges. The jungle environment seems to require different tools entirely. Special Forces units request machetes, axes, specialized clearing equipment. They receive them, but they keep the M1943 as well. In tunnel warfare, where Viet Cong fighters emerge from underground at point-blank range, the entrenching tool proves invaluable. Tunnel rats, the soldiers who enter enemy tunnel complexes, often carry an M1943 instead of a bayonet. The enclosed spaces make rifles difficult to maneuver. A pistol provides ranged capability, but if the pistol jams or runs dry in the darkness of a tunnel, the shovel ends the fight. The weight that makes it less than ideal for digging provides momentum for devastating strikes in confined spaces. The tool continues in service through every subsequent American military action: Grenada, Panama, the Gulf War, Somalia, Bosnia. Each conflict demonstrates that despite advances in technology, soldiers still need to dig fighting positions and close combat still occurs. The M1943 serves both requirements. By the 1990s, the design is more than 50 years old, unchanged since Barnes's original drawings. Logic suggests replacement with modern materials, titanium for lightweight, synthetic handles for weather resistance, folding mechanisms with complex joints for compact storage. The Army even develops replacement designs. Soldiers ignore them. Special operations forces prove particularly resistant to change. Delta Force, Navy SEALs, Army Rangers all maintain the M1943 in their equipment tables long after conventional infantry units adopt newer designs. When asked why, the answers emphasize reliability over innovation. The M1943 has no complex parts to fail, no synthetic materials to crack in extreme cold or deform in extreme heat. The steel blade, properly maintained, remains sharp indefinitely. The three-piece construction means field repairs can be made with minimal tools, and the combat effectiveness, proven across 70 years of warfare, requires no modernization. Violence, unlike technology, doesn't evolve. Afghanistan and Iraq prove the tool's enduring relevance. American soldiers, fighting in environments ranging from mountain peaks to urban slums, still carry M1943 entrenching tools. The design appears in photographs from Tora Bora, from Fallujah, from Kandahar. In 2007, a Marine Corps after-action report from Ramadi notes, "The entrenching tool remains the most versatile item of equipment carried by the individual Marine. Used for entrenchment, obstacle reduction, close combat, and general utility tasks." The report could have been written in 1944. The tool hasn't changed. Neither have the requirements of ground combat. Modern production continues at multiple facilities. The original Barnes factory closed decades ago, but the design, long since in the public domain, is manufactured by dozens of companies worldwide. American military procurement continues to order M1943 pattern tools. A 2019 contract awarded to Ames Tools specifies 150,000 units at $11.45 per unit, a price that, adjusted for inflation, represents only a modest increase over the original 98 cents. The design requires no updating, no modernization, no improvement. It remains exactly as Barnes designed it in 1943, a steel blade, a steel handle, one hinge pin, 3 pieces, infinite utility. The commercial market offers insight into the design's success. Civilians can purchase functionally identical M1943 pattern entrenching tools from military surplus stores, outdoor retailers, and specialist manufacturers. These tools, marketed for camping and emergency preparedness, cost between $15 and $40 depending on manufacturer and finish quality. The specifications match the original military design exactly. Some manufacturers offer tactical versions with blackened finishes or serrated edges, but the core design remains unchanged. A civilian purchasing an entrenching tool in 2026 receives essentially the same implement Barnes designed 83 years earlier. The fact that the design hasn't required improvement in nearly a century speaks to its fundamental correctness. Production numbers tell a remarkable story. Official U.S. military procurement from 1943 to present day exceeds 15 million units. Commercial production, including foreign manufacturers producing M1943 pattern tools under license or as unlicensed copies, likely doubles that figure. Conservative estimates suggest more than 30 million M1943 pattern entrenching tools have been manufactured since the design's adoption. The tool has been issued to American soldiers who fought in World War II, Korea, Vietnam, Grenada, Panama, the Gulf War, Somalia, Bosnia, Kosovo, Afghanistan, and Iraq. It has served continuously for 83 years, longer than any other piece of individual equipment in American military history. Rifles have been replaced, helmets have been redesigned, body armor has evolved through multiple generations. The entrenching tool remains. Why does it endure? The answer lies in Barnes's fundamental understanding of design philosophy. Complexity creates failure points, simplicity creates reliability. The M1943 contains exactly 3 components, each made from the same basic material, steel. There are no plastics to crack, no composites to delaminate, no electronics to fail. The hinge mechanism uses a single pin that can be replaced with any appropriately sized rod in field conditions. The blade, being high carbon steel, can be sharpened indefinitely with basic tools. The handle, also steel, cannot rot, warp, or break under normal use. The entire tool can be disassembled and reassembled in less than 30 seconds with no tools required. The generous tolerances in Barnes' design allow the tool to function when damaged or dirty. Unlike precision instruments that fail when fouled, the M1943's simple hinge mechanism works even when caked with mud. The blade-to-handle interface doesn't require perfect alignment to lock in position. The weight of the blade itself provides sufficient force to keep the tool deployed during use. This tolerance for imperfection proves crucial in combat conditions where maintenance is sporadic and abuse is constant. The combat effectiveness comes from physics rather than engineering tricks. The blade weighs approximately 1 pound. The handle extends the wielder's reach by 18 inches. When swung, the combination of weight and leverage delivers substantial impact energy. A properly executed strike from an M1943 generates between 80 and 120 foot-pounds of force, comparable to a hatchet or small axe. The sharpened edge concentrates this force on a narrow line, allowing deep penetration of soft tissue and even bone. Unlike a bayonet, which relies on a thrust that can be deflected or turned by clothing and equipment, the shovel's chopping action delivers its energy regardless of intervening materials. Comparison to modern alternatives illuminates the M1943's advantages. Contemporary entrenching tools from various manufacturers offer titanium construction, tri-fold designs, integrated picks and saws, and weights as low as 1 pound. These modern tools excel at their primary function of digging whilst minimizing load weight. But combat effectiveness suffers. The lighter weight reduces impact. The complex folding mechanisms create failure points. The addition of features like saws and picks increases cost whilst decreasing durability. When military units have the choice, they consistently select the heavier, simpler, cheaper M1943. Reliability trumps innovation. The design's longevity also reflects an uncomfortable truth about warfare. Despite technological advancement, close combat hasn't fundamentally changed in a century. Soldiers still find themselves in situations where their rifles are empty or unusable, where the enemy is at arm's length, where survival depends on simple, brutal violence. In these moments, the M1943 provides the same advantage it did in 1944: reach, impact, and reliability. Modern soldiers, equipped with night vision and satellite communications, still need to hit the enemy with something heavy when all else fails. The shovel serves that need as effectively now as it did 80 years ago. The tool's psychological impact deserves consideration. Unlike a bayonet, which is designed solely for killing, the entrenching tool maintains plausible utility. Soldiers carry it for legitimate, non-violent purposes, digging, chopping wood, clearing obstacles, but they sharpen the edge, they practice with it. They know, even if never stated explicitly, that the shovel on their belt might save their lives in close combat. This knowledge provides confidence without requiring acknowledgement. The tool doesn't declare itself a weapon, yet everyone understands what it can do. Field modifications reveal soldiers' trust in the design. While issued equipment often receives unofficial improvements, the M1943 generates remarkably few modifications. Soldiers sharpen the edge, occasionally wrap the handle for improved grip, sometimes paint or darken the blade to reduce reflection. But they don't redesign it, they don't add components, they don't replace parts with aftermarket alternatives. This acceptance of the design as issued demonstrates profound confidence in Barnes' original concept. When soldiers trust their lives to equipment without feeling the need to modify it, the designer has achieved something rare: perfect sufficiency. The absence of planned obsolescence in military thinking appears almost quaint by modern standards. Commercial products are designed with intentional lifespans, replacement cycles built into business models. But the M1943 was designed simply to work, with no consideration for future sales. Barnes created a tool that solved the immediate problem completely. The army bought millions because they needed millions, not because planned replacement would generate future revenue. This resulted in a design optimized purely for function, with no compromises for manufacturability beyond what was necessary to achieve the 98-cent price point. The remarkable result, a tool that requires no improvement 83 years later. Economic analysis reinforces the design's brilliance. At the original 98-cent cost, the M1943 represented approximately 2 hours of skilled labor wages in 1943. Modern procurement at $11.45 per unit represents roughly the same ratio to current wages. The inflation-adjusted cost has remained essentially constant because the manufacturing process hasn't required updating. Modern CNC machinery stamps out M1943 blades using essentially the same patterns that 1943 stamping presses used. The steel composition hasn't changed, the finishing process hasn't changed. This manufacturing consistency across 8 decades demonstrates design maturity that borders on the perfect. Consider the weapon systems that have come and gone since 1943. The M1 Garand, revolutionary in its time, served for barely 20 years before replacement by the M14. The M14 itself lasted less than a decade before the M16 took over. The M16 has undergone constant modification and faces eventual replacement by newer platforms. Helmets, body armor, boots, uniforms, field gear, all have evolved through multiple generations. Only the entrenching tool remains fundamentally unchanged. This persistence isn't conservatism or bureaucratic inertia. It's recognition that Barnes got it right the first time. The tool's service across conflicts provides validation through accumulated proof. World War II demonstrated the design's basic soundness. Korea proved it worked in extreme cold. Vietnam validated performance in jungle environments. The Gulf War showed it functioned in desert heat. Afghanistan tested it at altitude. Iraq confirmed urban applicability. Each conflict added evidence. Each environment proved the design's universality. By the time American soldiers were carrying M1943 tools in Kandahar, the implement had functioned in every climate, terrain, and combat situation imaginable. The case for replacement requires arguing that something fundamentally new has emerged that Barnes didn't account for. But ground combat, at its core, hasn't changed enough to matter. The Special Operations community's continued use provides perhaps the strongest endorsement. These units, equipped with unlimited budgets and access to cutting-edge technology, choose to carry an 83-year-old shovel design. Delta Force operators conducting counter-terrorism missions with night vision and suppressed weapons still strap M1943 entrenching tools to their packs. Navy SEALs, infiltrating by submarine and exfiltrating by helicopter, carry the same basic implement that was issued to their predecessors storming Normandy beaches. This isn't nostalgia. Elite soldiers are ruthlessly pragmatic about equipment. They carry what works. The fact that they continue to carry the M1943 when unlimited alternatives exist demonstrates that nothing has emerged that works better. The civilians who purchase surplus M1943 tools provide additional validation. These aren't collectors acquiring historical artifacts. They're preppers, campers, and outdoors enthusiasts who need functional equipment. They choose M1943 pattern tools because the design works better than modern alternatives. Online reviews consistently praise the tool's durability, simplicity, and effectiveness. Users report the same advantages soldiers discovered 80 years ago. It's heavier than modern options but more robust, simpler to repair, and more versatile. The fact that civilian users, unconstrained by military procurement bureaucracy, independently choose the M1943 design proves its superiority through market forces. Some weapons revolutionize warfare. The machine gun changed infantry tactics. The aircraft carrier redefined naval combat. The atomic bomb altered geopolitical strategy. The M1943 entrenching tool didn't revolutionize anything, it simply solved a specific problem completely. Soldiers needed to dig fighting positions quickly in varied terrain. They needed a tool that wouldn't break, wouldn't jam, and could double as a weapon in extremis. Barnes gave them exactly that. Nothing more, nothing less. The design's perfection lies not in innovation, but in optimization. It is exactly sufficient for its purpose, with no excess and no deficiency. The tool was supposed to cost 98 cents and last through one war. Instead, it has served through 8 decades of continuous conflict, been manufactured by the tens of millions, and remains in frontline service with the world's most capable military forces. Soldiers have carried it from Normandy to Kabul, from the Chosin Reservoir to Fallujah. They've used it to dig foxholes and kill enemies, to clear obstacles and save lives. The simple 3-piece design that John Barnes sketched in 1943 has proven more durable than complex weapon systems, costing thousands of times more. It works in frozen forests, it works in burning deserts, it works in steaming jungles, it works in urban ruins. After 83 years and millions of rounds of the most brutal testing imaginable, the M1943 has proven one thing beyond doubt: simplicity, executed perfectly, achieves immortality.